So this is the basic premise of how the hydraulic ram operates. We have a flow of water. We have to have a flow of water. We have to have some head height of water here that's driving the water through a pipe. We have an impulse valve. This is a valve that is going to slam shut suddenly and generate a pressure wave that's going to move up this pipe. And what we're actually going to do is we're going to put this valve on a spring so that the spring will serve to push the valve open. The force of the water moving will push the valve closed. As the valve closes, that generates the pressure wave and the hydraulic ram effect. Then the spring pushes the valve open again. The water starts flowing. Once the water starts moving again, now again the force of the water is sufficient to push the valve closed. Once the valve's closed, we have the hydraulic ram, but with the flow of water stopped, the water can no longer hold the valve closed, so it pushes open again. If the impulse valve is correctly adjusted, it oscillates. Up and down, up and down, up and down, up and down, and we just get a whole constant series of pressure waves running through our piping system. What we need to do with the pressure wave is to trap it. So that is the function of a delivery valve, and that is really quite simple. You can devise various designs for the thing, but the idea is it only opens when the pressure in this lower region is fairly large. The delivery valve opens, allows water up into the delivery system, and then when the pressure in the bottom part drops, the delivery valve closes and traps the high pressure water in the delivery system. Constant oscillation of the impulse valve generates a whole string of pressure waves, a whole series of pressure waves continuously in this lower part of the hydraulic ram, and then every time there's a spike in the pressure, the delivery valve opens, allows a little bit of water to pass through into the delivery system, and if we have a large column of water here, what ultimately happens is we just get a buildup of high pressure water at this point, and we can just connect a pipe to it, and admittedly at a rate considerably less than the water is flowing through the bottom part of the valve, we'll be able to deliver high pressure water out of the ram.
Well, I started with this Peace Corps design. It's just this diagram you see here, and maybe a page of explanations as to how to construct the thing that, I doped it out, but it wasn't the clearest thing. More importantly, though, I ultimately ended up changing the design around. The big thing was the stroke adjustment on that lower left-hand T that's the impulse valve. This is what I ended up with. We have just as in the Peace Corps design, the impulse valve is constructed around a 1 1/4 inch T. We have coming into it a reducing bushing that connects to a short length of 3/4 inch PVC pipe, and then a connector to hook a hose into it. The actual impulse valve assembly is connected into the T by a short length of 1 1/4 inch pipe, and then there's a cap on it. It's not a regular cap, but it's actually made the way the Peace Corps design described it, which is it's basically half of a coupling and half of a 1 1/4 inch coupling and half of a 1 1/4 inch reducing bushing glued together in order to form a cap that has a flat surface. That's the surface of the reducing bushing for the valve to act against. I didn't use the Peace Corps design for the valve. What I use for a valve is, well, first of all, a flap connected to a spring glued to a bolt. They're both, where the flap was glued to the spring and the spring was glued to the bolt using epoxy. And then the bolt is threaded into a nut. The nut is mounted onto the frame so that by moving the bolt around in the nut. It allows you to move the bolt up and down. It lets you move the whole spring and plunger assembly up and down. And that's the stroke adjustment on the impulse valve, which I'm ultimately a lot happier with than the one on the Peace Corps design. Coming back out, we see that just as in the Peace Corps design, it's connected to the delivery valve with a 3/4 inch length piece of tubing that has been heated and bent into a 90-degree angle. There's reducing bushings on both ends of it. On the upper right T that forms the delivery valve, what I did instead of, again, I changed the Peace Corps design around here. What I used is a very short length of 1¼ inch tubing pushed inside the T, and then I put a piece of rubber in between that and a reducing bushing, and then I cut a horseshoe shape into the flap so that the reducing bushing acts as a flat surface again for that valve to close against when the pressure in the upper T is higher than in the lower pipe. And then the short length of 1¼ inch tubing there provides, a spacing. The reducing bushing doesn't really go all the way into the T anyway because the T is tapered. But really what that short length of 1¼ inch does is it just firmly seats the edge of the valve so that it's held firmly in place against the reducing bushing, and so that it closes cleanly and opens cleanly as well. Then, just as in the Peace Corps design, there's another reducing bushing, another short length of 3/4 inch and a 3/4 inch connector for a feed pipe going out, a delivery pipe, delivery hose, whatever you want to call it. And then there's a large piece of about a foot long of 1¼ inch pipe that's plugged into the top of the T, and it goes up to a regular 1¼ inch cap that you can't see in this diagram. But that's the same as the Peace Corps diagram. So that's what I ended up with as what I actually ended up building, as opposed to what I started building, which was essentially the Peace Corps design. And this is, you can still see the influence of the Peace Corps design. It's 75% the Peace Corps design, and then I ultimately changed around the valve designs a bit. Both of them I'm a lot happier with. I'm a lot happier with the impulse valve design because it really just very clearly there's a spring action that it's just very clear what that valve is doing. I was never quite clear on how the PVC flapper spring worked in the Peace Corps design, and I'm also a lot happier with the impulse valve because the delivery valve, because it is much simpler than the Peace Corps design. And I should also point out there's also a snifter valve. That's exactly the same as in the Peace Corps design, which is to say there's a hole drilled through the entire reducing bushing and pipe, and then there's another hole drilled from the outside up to meet that first hole, and we put a bolt into the first hole. And if the bolt is all the way closed, all the way in, then that it essentially doesn't affect the system at all. But if you take that bolt out, then it exposes at least part of the other hole, so air is allowed into the system, and thus it allows you to introduce air into the system in a controlled manner. And I'll probably talk at some point about just why you'd want to do that. But that's the snifter valve. That's the same design as it was in the Peace Corps.